Join discord.gg/flatearth and enter a check-in room. Someone will come along and verify you to get involved in the conversation about our Earth.
Discussion because we have somebody that talk.
Oh, go ahead.
RocketMan24, you're on the air. We're going to discuss how rockets work in a vacuum, not a vacuum chamber, in the ever-expanding vacuum of space.
Hello, everyone. How you doing? How you doing all this evening?
Good.
We are great.
Good. I hope you're good.
Looking forward to this conversation.
Hey, Rocket Man, we wish you a happy stationary topographical plane day.
And I wish you a very happy rotating spherical day.
You can't prove any of that.
Tit for tat.
You can't prove any of that.
You got a rad one? Have you been having a conversation with him, have you?
Well, we did the other day. His internet went out. I remember that.
There was a storm coming over here.
Yep, absolutely. We remember it. So we will continue. As Amish asked if he wants to type it in, but I forget. But the question is, how does a rocket move in a vacuum of space? Ever-expanding vacuum, not walls, in a vacuum chamber that can fill up with gas.
So, quite simply, Newton's third law. I'm sure you're all very aware. Every action has an equal and opposite reaction.
Yes.
A mixture of oxidizer, kerosene, or whatever, RP1, whatever fuel they're using at the time, gets vaporized, aerosoled, and mixed in the exhaust chamber, ignited with a source. That causes the gas to expand and rush out of the exhaust nozzle. This impedes a lot of force on the gas and shoots it out of the exhaust nozzle. And as there is a large amount of force causing all that exhaust to eject out the nozzle at incredible speeds, there is also an equal force acting in the opposite direction on the rest of the rocket, causing it to move in the opposite direction.
But hold up. Because there's nothing for the gas to press upon, there is no equal and opposite action. Sorry.
It's the force of acting on the exhaust to shove it out of the exhaust nozzle that's acting on the rocket.
Okay, great. But if the force is shooting out into nothing, it has no force anymore because it doesn't have anything to push against.
No, because the force is acting on the gas inside the exhaust chamber, not
and it's
causing the exhaust to leave.
It's just going. It's just going like a balloon would, like it would just flip all the. It wouldn't be pushing on anything. You have no equal and opposite force unless the gases are pushing on something to make an opposite force. You don't have that.
Your outer space fairy tale is a violation of Newton's third law of motion, because in the final analysis, there is nothing that rocket can push off of in the vacuum of 10 to the negative 17 torr. There's nothing it can push off of there, because there's no air, it can't ignite either. So you have no propulsion and you have no ignition possible in that fairy tale. Now you can believe what you want to believe, but what you believe is a violation of Newton's third law of motion. There is no propulsion possible and there is no ignition possible because there's nothing to push off of and there's no air. So you believe your fairy tale and you tell us your fairy tale and we'll believe in Santa Claus too.
It doesn't need a surface to push off.
Yes, it does. That is Newton's third law of motion.
So
I've got like 5 minutes. I just want to ask him a question.
Sure.
You're going to give us a demonstration of a smaller version of this in a vacuum chamber, aren't you?
No, because it's the only video I've seen, the one by Action Lab. I don't really like that video.
Yeah, because you know why?
Because you'd like to say that the small vacuum chamber fills up with the pressurized whatever's in the can, and that's what it's pushing off.
As soon as the gas is released, it's not a vacuum chamber anymore?
Absolutely. I preface this conversation with, you will not give us a demonstration of a rocket inside a vacuum chamber with walls that can fill up with gas for the rocket to move.
Yes. So if the sun is like this nuclear reactor and it's like has these like sunbursts that push out a bunch of energy, will it push the sun in the direction
a
opposite
minute amount, yeah.
Shut up,
Interesting.
man.
Minute amount.
Hey, Rocket Man, if you put a hey Rocket Man, if you put a candle into a glass and remove all the air, and so it has no air, will the candle continue to burn?
No, because there's no oxygen.
Okay, so there's no oxygen in outer space. Thank you for playing.
The sun isn't. It's a plasma. It doesn't need oxygen.
You have no idea what the sun is. It's 91 to 94 million miles away. There is no medium or anything like that that can transmit heat without molecules. You also have a violation of the physics of light and the physics of how light travels, because light doesn't travel. And your little fairy tale, we're going to demolish your little fairy tale. If you want to continue to believe in your textbooks and your outer space monkey religion, go ahead. But we're not going to let you, because there's a bunch of warriors in here that are not going to allow you to lie to us, because the majority of us have been lied to us our whole lives, and we're not going to be lied to again.
I could actually show you nuclear fusion in a vacuum, if you'd like.
You don't know what the sun is. You have no clue what the sun is if it was in your fairy tale of 91 to 94 million miles away. You have no clue what it is.
Okay.
True or not true?
We're going to stick to the rockets in the vacuum.
Yeah.
Right. So your demonstration of rocket propulsion in a vacuum chamber is null and void. So what have you got next?
Well, I would like to say, so you know how you guys are saying that, and I don't want to straw man, so correct me if I'm not getting it exactly right. You need a surface for the rocket to push off for propulsion.
Not a surface, but you need something.
Yeah, no, nobody's saying it.
Okay.
Yeah.
Like, I'm not trying to use this against you. I just want your thoughts, just to like think about. I want to see how.
We just want you to explain rockets in a vacuum.
Yeah. So, if you have the ground, very solid, very dense. When the rocket exhaust is coming out and it's hitting that surface, which you claim is causing the propulsion.
No, it's one of the reasons it causes propulsion. You have water with a submarine, you have air with an airplane, you have somebody who jogs, so it doesn't have to be a solid surface. It can be the air, it can be the water, it can be a solid surface. Please don't strawman our position.
I wasn't saying it was the sole reason, but I was saying that if there is a concrete surface underneath a rocket, it is mostly pushing off the concrete.
Where are you going with this?
If you give me 30 seconds, I will get there. So it's pushing off the concrete surface. Would you, like, genuine question, would you say it pushes off the concrete surface more than it pushes off the air?
Yeah, because it's solid.
Hey, make your point, bro.
Yep.
My point is, as the rocket gains altitude, we know that it accelerates. Why does it accelerate if it's pushing off less and less air instead of concrete?
Pushing off the air.
But if it's not pushing off a lot, why is it still accelerate? There's not a lot there for it to push off.
So you're claiming
the liquid weight that's in the tank.
But you're actually claiming that these things actually go these speeds that you're claiming they go. So how do you prove that they're going these speeds that they're going?
Well, for example, I've launched a model rocket recently, and that had a altimeter and speedometer on it, and we tracked the data from the launch.
What's the speed? Is that going off airspeed?
It's got yes, and also GPS.
And the altimeter goes off barometric pressure, correct?
Yes, it does. Yes.
Yep. So they're both not accurate.
See, Rocket Man, pushing off the ground, pushing off air, pushing off water, pushing off whatever is not a violation of Newton's third law of motion. Pushing off the vacuum of outer space where there's no air, no ignition possible, no propulsion forward possible is a violation of Newton's third law of motion. You invoked Newton's third law of motion when you came here as evidence that something can happen that it really can't happen. And you see, we're going to call you out on it every single time because it is not science, it is anti-science, it is non-science, it is pseudoscience.
Okay. So I've been doing research to see how I can kind of best explain it to make sense.
You can't explain anything because anything you explain is a violation of Newton's third law of motion.
Okay. So
are we talking about how rockets work in a natural law violation sky vacuum?
Yes.
Oh, okay.
Not in a vacuuming box that, NASA has down the street from me. Because that rockets will move in there eventually.
Okay. So yeah, think of it this way, if you're on a chair with wheels on it and you're on an ice rink and you've got a bowling ball in your hand and you push that bowling ball away from you, you're going to roll back in the opposite direction. Now, the reason you're rolling back is because you're rolling back with the same force that you inflicted on that bowling ball to push it forwards, and the bowling ball is pushing back at you, causing you to roll in the opposite direction. Now, there will be some initial pushback from the air, but very slight, but most of the force pushing you backwards is the force you exerted on the bowling ball, and the bowling ball exerting the same force back on you.
And then you got momentum. Momentum is a totally different thing here on Earth than it is in your fairy tale of outer space. Guys, RocketMan, we are not dumb. We know your script. We know your globe script. We were all globers. We all believed in the fairy tale. We don't believe in the fairy tale anymore. You got to come with us more with a bowling ball in a skating rink being pushed off of to equate or invoke your outer space monkey fairy tale religion where there is no propulsion possible. There is absolutely no ignition possible because you don't have those possibilities here on Earth. And when they're tested here on Earth, they don't work. You put a candle into a glass, remove the air, the candle goes out. You have no air in outer space, your fairy tale of outer space. There is no ignition possible. So you continue on with your fairy tale, and we'll enjoy Santa Claus, the Tooth Fairy, and story time.
Do you put candles out, by the way? I just put a lid over them.
Do any of you agree with the analogy I just used with the bowling ball on an ice rink? Is the reason I'm going backwards due to the force that I inflicted on the bowling ball pushing back at me?
However you want to call it, but that just happened on regular Earth.
You know why that's happening though? Is due to the medium you are sitting on and in. It's all due to your medium.
Correct. Air. You're in air.
You're not in a vacuum, so using that as an example has no relevancy whatsoever. You need to have an example that is also a vacuum.
Why is the air making a significant impact on the?
It's not. You're on ice. You're using a solid medium versus a vacuum, which is absolute lack of.
If let's say you were free falling and you pushed a bowling ball, you would also be pushed back.
Nope. Air medium. Force. Air medium. Again, there is a medium. There is no medium in space. There is a lack of. You don't understand that concept.
Yeah, there's no force in a vacuum.
RocketMan, why are you moving around in the medium of air? You're moving that air and creating air pressure. Air pressure moves things, believe it or not. Because I use air pressure in my garage to blow my garage clean.
So, are you saying that the bowling ball inflicts no force on me when I push it forwards?
You're dealing with air, you're dealing with an atmosphere or an atmos, you're dealing with things that you do not deal with in the fairy tale of outer space. RocketMan, one question before I have to go. Why is it so important for you to come into a flat Earth server and defend your spinning space ball in the vacuum of outer space? Why is this so important to you?
It's not. I just enjoy other people's views on the world.
Fair enough. Thanks.
No problem.
It's not really a view, though. We just go by facts. That's the problem here.
Yeah, so I don't think an astronaut holding a bowling ball in the vacuum of space could actually push that bowling ball away from himself.
Why?
How come they haven't shown a video of that on the ISS yet?
Because they're not there to try and prove established physics. They're there to run their own experiments.
Okay for
Yes,
them
they
to
are.
prove,
That's exactly why they're there.
it's okay for them to prove that they can fly around in gorilla suits.
Why did you say established physics? Why did you say that for?
Because it's been the consensus.
Okay.
Doesn't make truth.
Okay, so in other words, your outer space monkey religion fairy tale is a violation of the inverse square law of light, Newton's third law of motion, second law of thermodynamics, but it's established physics. Is that what you're saying?
Those were a lot of words. I'd have to take them apart one by one. I'm gonna say no as a safety, but it's that was a lot to unpack in one go. And if it's okay, I would like to remain on topic. I'm not trying to run away, but just for the ease of conversation.
That's good. Yeah, I think from I've had some conversations with people who used to believe, in the ball, and we advocated, we gave up the idea that we were going to fight the Newton's third law of motion, outer space travel, and we were going to move on to other things. We should have never ever left that topic, because that topic of something pushing off of nothing, igniting with no air, is so darn damning to the globe religion, it's not even funny. But we have let people say it 100 times for every time we said it can't happen. And so we kind of said, well, we can't really deal with them. I'm telling you what, guys and ladies, we just need to deal with that alone. Just like we need to deal with water being, a large body water being, not curved or being flat. We can die on that hill, because they have no way to tell us that 71% of something curves, because they can't prove their gravity, and they can't prove boats over the horizon. They can't prove any of that stuff. So we just need to hang tight and let all these people know that come in here and who we see in the real world what the truth is. And what Mr. RocketMan is pushing, and it's okay, he's been brainwashed, indoctrinated like everybody else, that he's pushing pseudoscience. He doesn't know it, but he's pushing pseudoscience.
And it's called chemical inertness.
What's chemical inertness?
It's the properties of the chemicals that ignite.
Oh, right. Yes. Yeah. Okay. Is it possible, the bond ball analogy? Is it okay if because I wasn't quite finished where I was explaining the analogy. I know people didn't really like it. Is it okay if I continue, or would you rather ask another question about it?
Well, I'm going to ask a question about your bowling ball and the human. In your rocket, which is the bowling ball and which is the human in your rocket?
The bowling ball would be the gas particles, and the human would be the rocket.
Okay, I have a question.
So now you got a problem. Now you have a problem.
Oh, now you got a problem.
Your exhaust is going faster than you can push the entropy in a vacuum where that gas wants to go is faster than that exhaust. So what's it pushing off of?
What do you mean? The entropy is faster than the
What he means is the gas is being sucked out by the vacuum faster than anything that would be used as propulsion.
Right. because vacuums don't suck.
Listen,
Yes, they
we're
do.
not
They
talking
balance
about
out.
sucking. Listen, the pressure from the exhaust would leave the exhaust and go into the vacuum. That's all it would do. It would just going into the vacuum because that pressure differential is basically the gas is going to fill the available void. So if it's nothing but void out there, there's nothing to stop it from just exhausting out.
I'm going to give you an example. I'm going to give you an example you can do. Take a glass ball in a vacuum chamber, however you want to fill it with smoke or that gas they're using there, colored it, and break that glass. Your vacuum chamber will instantly fill all the corner, sides, walls, bottom, top, inside of it, everywhere, equally, instantly. Not you pop it and then all of a sudden you see it go phew, like a little cloud. It's an instantaneous thing. I work in a lab.
Your exhaust would go out in all directions, and you would have no direction for your exhaust. Right?
I'd like to say, first off, it wouldn't be instantaneous because nothing is instantaneous. You can't have zero time. I'm sure if they used a high enough speed camera, you'd be able to watch
exhaust.
No, because when the fuel in the containers they're pressurized, they're sealed off, airtight, so the exhaust can't escape on its own. The exhaust then gets pushed through the plumbing system and accelerated, so when it reaches the exhaust chamber, it's instantly ignited when they use hypergolic fuels, which just ignite the moment they come in contact. So yes, they might be getting pulled out, but the moment they enter the exhaust chamber, they mix and combust, which exerts a force on the gas particles, forcing them out even faster. And I'm talking kilometers a second. And that force is exerted back on the rocket.
The negative 17 torr is going to pull that out faster than what you're talking about. So listen, you talked about plumbing, right? So what plumbing is able to hold the gases that are in that, whether they're in liquid state or not? What plumbing can hold back 10 to the negative 17 torr engineering-wise? Like O-rings or seals? Do you have the data for that, the engineering data?
I would just... there's plenty of...
Suits or cloth. Listen, add cloth spacesuits to that list with zippers.
Yeah.
Well, I think you couldn't have sustained you couldn't have sustained projection. You like it would have to close off, reignite, close off, reignite. Like you wouldn't have like a constant flame, like from the back of the rocket once you were in the vacuum.
And also, your analogy of bowling balls doesn't apply. Gases are not bowling balls. They don't behave anything like bowling balls.
Well, matter interacts the same. It doesn't matter what state it's in. To go back to the other ones, first off with the plumbing, there's loads of standard grade airtight seals. You get them on small little vacuum bell jars. You can get. There's loads of standards.
Great. So show us that the engineering can handle a 10 to the negative 17 torr, and I'll be satisfied. Show me that.
Yeah, after the conversation, I will, if people are still around, I will get a link up. I'll post it in chat. If I do forget, please remind me. I'll be in chat. Please remind me, because I just want to address the other points as well, if that's okay. But I will.
It's all right. I know you don't have it because they don't have anything they can test it with here on Earth. That's the problem, buddy. Like, they would have had to test this in the environment that they're going to, right?
What's funny is I create 10 to the negative 22 at work, so we can test valves that only can test at around 7, because you really can't get it any better than that. We make the best there is, and you can't get it any better than that. Those are our specs. And we test, and our container that we do it in is only about 8 inches in diameter, and it's a bell jar. It has one sealing surface, and that's at the very bottom. So how many sealing surfaces are there on the ISS or in a spacesuit? Let me guess. On a spacesuit, probably around, I don't know, 1 million. On the ISS, I'm going to guess around 10,000 maybe. So those, how do you check that? How do you get that in a vacuum chamber to pressure test that? Because you can't, OSHA won't allow you to do things where humans are involved without pressure testing the equipment. We write the OSHA laws with OSHA about it.
RocketMan, where do you get your information from?
Regarding what specifically?
The idea that a rocket can push off of nothing in the vacuum of outer space, and that fire something can ignite in the vacuum of outer space. And where do you get that information from?
Initially, the internet, but then secondly, my university professors.
Okay, so university professors. Okay, it's cool. What if your university professors came out tomorrow and said, "Hey, guess what? I don't see. I can see much further than I should on a ball of 3,959 miles, and outer space travel violates Newton's third law of motion, second law of thermodynamics, inverse square law of light." What would happen to those professors tomorrow if they went to school and started teaching that?
Well, first off, they would need hard kind of evidence and rigor.
RocketMan, we do have hard evidence. You have a fairy tale. Help me out.
I'm probably the wrong person to argue. I'd probably talk to someone who's written a research paper about it. Mm-hmm. I'm still a student. I'm in a few years. I've got an internship next year, either at Rolls-Royce or another space company. If I do some vacuum tests and rocket propulsion, because that's what I'll be working on, I'll be happy to send you my findings.
You won't be doing those in that, and you won't be doing those in lab. So just letting you know ahead of time.
Can you do me a favor when you go back to your school, or maybe even this summer, email one of your professors, ask them to come on here so we can talk with them?
I can ask, but they're probably very busy, and
they're not.
I could try. I could
possibly be talking about air pressure.
The researchers, so they do a lot of research, and they also work in the industry in the meantime as well.
You can ask to them this: can you have gas pressure without a container? Ask this question to them. And by the way, do you trust NASA, right? And rocket SpaceX? Do you trust? They are showing the truth.
Yeah.
Yeah. So explain this.
Sorry, I can chat.
What is this rat passing by this rocket? Do you want the original video?
Some eyes.
The original video is from NASA YouTube channel.
Yeah, it's probably ice that's collected on the side of the rocket.
Ice. That's cognitive dissonance, baby.
Okay.
Maybe you can watch more rats in the National Geographic, okay? You call ice to that?
Yeah, because there's a lot pretty much on every rocket. You get sheets of ice in the same places.
There's a lot of cognitive dissonance, when you see a mouse passing by in that rocket. Yeah, you can. Space may be the final frontier, but it's made on the basement. Okay.
I'll tell you what. I've seen how large those engines are. That's a very big mouse. I'll tell you that. That's probably a cat-sized mouse. It's probably a cat-sized mouse, something like that. That's a very big mouse.
It depends of when the camera is, when you can shooting close to the mouse or far away. But okay. Okay.
So the size of the mouse matters. Eh?
Well,
I don't know cat-sized mouses exist or how you'd manage to.
I don't understand how can this rat be in space, in that rocket.
Maybe because all is.
Because they can use all smoke and mirrors, to fool us.
Yeah, there is no rockets in a natural law violation sky vacuum. There's no natural law violating sky vacuum.
What's your guys'
That's
opinion
the elephant in the room.
when people have from the ground live uncut footage of the rockets that land themselves again?
Yeah, so what? So if Hollywood can do even better tricks than that. They could probably do a loop-de-loo, and then land it. So who cares? These are images that you're looking at on the video screen. This is the problem, because people are believing this spinning Earth in a vacuum that can't exist in reality, based on only moving pictures. Like your TV screen is the only place you've ever seen any of this. So telling us that you have something on another TV screen doesn't cut it. Bro, listen, check this out. Your whole thing is that Earth is a spinning ball in a vacuum of space, right? Isn't that where you're culminating to?
I mean, the main discussion was just about rockets in space.
Rockets, okay, but you believe they're sending these rockets out into the vacuum of space, right?
Near vacuum, but yeah.
Okay, you think they are. Okay, so therefore you think Earth is also a sphere, right?
Oblate spheroid, yeah.
Okay, great, an oblate spheroid. What proof do you have that Earth is an oblate spheroid?
There's lots. I did ask if it was okay to keep on the topic of rockets. If you want, I'm more than happy to talk about it in chat later.
We're just gonna cut to the fucking chase here. Earth is supposed to be curved, so on the surface, where's your proof on the surface of drop over distance? Period. Do you have it?
A lot to talk about rockets.
Do you have drop over distance tests?
Just because you would like to talk about
hold on, I wasn't done. I need you to provide drop over distance tests, numerous ones. It needs to be repeatable, that verify and validate the radius of 3,959 miles.
I'm sure there are lots of people who have done it.
Okay, I'm sure you think there. I'm sure you think you're sure. But what I need is actual. No, I need the actual fucking proof. So put the drop over distance data in the live stream voice text.
Let me put it to them in a different way. In order for you to launch your rocket that you want to launch, you need the radius of Earth. So how did you get it? And how did you measure it?
Why do we need the radius of Earth to launch rockets?
I thought you said that you were a national physics student.
Put in your rocket to orbit the fucking thing, right?
You need the distance between the center of two masses, my friend. It's in orbital mechanics, and it's in the velocity. Yeah, right.
Aren't you in university? Don't they teach you this in university?
I'm doing aerospace engineering.
Right, which is dependent on what's being told to you now.
Yeah.
Two things at question then: vacuum of space or the ball bit underneath. You have to have proof of both of them, but especially one, the Earth being a ball, and you can only do that through a direct measurement and proof of it. The vacuum of space, that's a violation of the second law of thermodynamics, so RocketMan, I'm afraid there is no space for a rocket to go into in the first place. Otherwise, we wouldn't have and understand that law as it is. So, I know it's maybe the burden upon you that we're not necessarily trying to demonstrate. It's the burden upon them who claim the Earth is a ball in the vacuum of space. The pictures from it or the stories about it don't cut the mustard. We need proof of the actual story to actually talk about the story to begin with.
I'm not trying to be facetious, could I ask for your standard of evidence of what you'd like to be presented and would accept as proof to make my life easier?
Awesome. So that would be dependent upon the question. There are three primary claims that they make about what the Earth is and does. That would be a ball, so that would be direct measurement of curvature, drop over distance, as Sonny was pointing out. Motion of the Earth, what the Earth, the ball, is said to do, so direct measurement of the motion of the Earth. And then you'd have to show and demonstrate a violation of the second law of thermodynamics, and then demonstrate an entropy decrease, where we all understand entropy increases.
Okay. Well,
understand, right? If the Earth is a ball, then we should be able to observe that ball and measure that ball. So that's why we talk about measuring it. The R value within the calculations, yeah, that's the measuring bit. We need to prove that bit before it goes into the calculations.
Yeah. I mean, when I did this, I went into talking about rockets, so I will have to look up some and read through some sources to find one that hopefully you would accept.
So what's the question that you're asking? In which regard? What, rockets?
No, the curvature, the direct measurements of Earth's curvature and stuff like that.
Yeah, RocketMan, all we need is drop over distance of 8 inches per mile squared, please. If you can show me where I can go to the Grand Canyon, look over long distances, look across Lake Michigan, and I can see 8 inches drop, and I can't see Chicago. I can't see the rim of the west rim when I'm sitting on the east rim of the Grand Canyon because it's dropped 3,000 feet because there's 70 miles at 6 feet observation height. If you can show that to me, I'm back to the ball, man. I tell you, I'm going to start playing basketball again, soccer, and have a globe in my bedroom at night because I love my globe.
The only issue is we don't use 8 inches per mile square.
What do you use?
I'd have to find the actual equation because it's very difficult to remember, but one that does include refraction.
No. If you want to play the 7/6R game, which adds 15% to your imaginary ball, go ahead. But I'm telling you right now, you should be able to show us 8 inches per mile squared on a radius of 3,959 miles, and not with your refraction, because you can never measure refraction. 7/6R is something that you guys have taken, but then if it doesn't work, you want more than 7/6R. So guys, don't play the game. Show us 8 inches per mile squared. That is simple geometry based on a radius of 3,959 miles.
Sorry. He can't.
Go for it.
Sorry, he can't because he said refraction. So that would mean that he's never seen the geometric physical curvature of the Earth known as the horizon, and no one has because of refraction.
That's right. What are we
going to do now? You've got a problem. We've pointed out that you've never seen it to backwards engineer anything to, and you can't just say refraction. What you're talking about, Snell's law, well, you haven't got two different mediums in the first instance. So we won't be talking about that then, will we? What type of refraction? Well, 7/6R. That's not bending of light. That's making the surface of the Earth bigger, so it looks flatter. So refraction doesn't cut it. I'm sorry, mate. I'm going to have to hand you a bandage, put you in the corner, and tell you that you might have to come back another time with something else.
Exactly, because he in order to do the geometry, you need to have established that there is a geometry to measure first before you can invoke that refraction. How are you going to do that if there's refraction that you're claiming is based on geometry?
Remember those calculations? The math needs to be proven first, right? Not just asserted. And, well, you've just shot yourself in the foot because you've never seen the geometry that you claim.
No, because I've not gone hundreds of kilometers up in the sky. But you can see the effects of curvature. You can see the effects of curvature.
What are the effects of curvature, my friend? Hold on. What are the effects? Sunsets. So when the sun goes down and you're standing at the beach and we see the horizon and the sun goes behind it, that's the physical geometric curve, is it?
Yeah.
But when the sun isn't there, just above it, that's not the physical geometric curve. It's an apparent location. I mean, what are we going to be talking about? Do you want the black swan image where the horizon moves around? We know the horizon moves around, so it cannot be a physical obstruction. Be a physical obstruction. When you declare that you see it, but how can you? We're looking through the atmosphere. You're just saying that because because the sun goes down now, ignoring the refraction bit, that's the curvature of the Earth. Did you not listen that when we make observations, you got to take the atmosphere out then for you to see the curvature of the Earth, not put a big light behind it?
I'm not using a sunset to determine the size of the Earth. I'm using the sun to determine there is a curve full stop.
No one said size. No one said size. Physical obstruction. The horizon is blocking the bottom of the sun. Then you need the horizon to be physical. Then it isn't physical. It's optical. Depending on the atmospheric conditions of the day, like fog or a clear day or whatever, and the technology that you use. Your eyes, binoculars, high-powered zoom cameras, telescopes, for example. The horizon demonstrably moves around. You need it to be physical You need it to be in the physical location where the math dictates. It's 1.2 times the square root of the observer's height in feet. So when I go down to the beach, that horizon for me, when I'm sitting down at 1 foot, should be 1.225 miles away. You're then saying that when I see a sunset, that's the physical curve of the Earth that I see, but it's not in its physical location. What?
So you did forget the perspective, you know.
No,
when you take out perspective from that your equation, you don't care about reality.
Okay. Firstly, responding to Jedi, the 1.22 square root of observer's height in feet, that ignores refraction.
Refraction, of course it does. Then back to your point,
and that just.
And then back to your point that you've got nothing physical to make these calculations on anyway, but you will assert that's the physical geometric horizon when the sun goes behind it. What?
There is a horizon.
Yes, there is a horizon because we're standing on a surface and the sky's above it, and it's the limitation of our view across it.
No.
Well, where's the curve bit then? You're saying it's physical obstruction, but we don't see the physical obstruction at 1.225 times the square root of the observer's height in feet until you magically assert it when the sun goes down.
You see the physical obstruction when the sun disappears behind the giant curve of the Earth.
Again, just assertion, but you're missing out. The horizon's not physical Earth curve. For it to be physical Earth curve, it must be where the mathematics dictates that the calculation mean you keep spouting backwards and forwards. But that's the thing that you need for physical obstruction. It's not physical if it's optical now, is it?
The horizon is just how far your line of sight can see until the curvature of the Earth.
Until the curvature of the Earth, which is at 1.225. Until the curvature of the Earth, 1.225. But now you're going to say refraction, declaring that you've never seen it in the first place. How can you backwards engineer refraction to a phenomenon that you've never seen in the first place? You're just asserting that it's there and remind us that we don't see it until you blindly declare that we see it when the sun goes down.
Refraction only allows just
no.
Tracks.
You see this. You see this GIF about the sun. When you zoom out, you zoom in. You see that horizon. So the sun is not going down; it's perspective, and because you forget that human eyes have limitation, you know, and you forget that when you claim about refraction, show me refraction at left and right, okay, in that horizon. Okay, by refraction. Sorry, it's a fairy tale.
I can add a solar filter, and that will neglect.
I can choose you a solar filter. Like, yeah.
Sorry. What type of entertainment fallacious bullshit is this? I can. Have you?
Yeah, I can get the video up now.
Awesome stuff. So with a solar filter, you might be able to demonstrate something. Brilliant. Do you want me to go and get a solar filter and demonstrate the angular size? But that'll still be dependent on a few fucking things. And we're looking for physical obstruction, remember? That's what we're looking for. So let's not start skipping past it.
Yeah.
RocketMan, why are you making shit up?
I did post with
you said that a solar. You said that a solar. I heard what he said. I just heard it on the live stream. He said a solar filter gets rid of refraction. That's what you said. That's nonsense.
It takes out the glare of the sun.
It takes away the glare, but you can't.
What is glare? Tell us the physical mechanism. Yeah, I know. I know how we describe it. I want to know the physical mechanism. What is it?
It's the light refracting off the surface of the lens that's causing glare.
Yeah, you got a citation for that? Like, seriously? Because my understanding is nobody knows what causes glare. They actually researched it. They basically stopped researching it because there is no answer.
Well, you said that a solar filter negates refraction, so you're saying that with a solar filter you see the geometric horizon?
Yeah.
Really? Okay, I'd like to see that shit.
So I have a video of a solar filter. This was taken by astronomers in Chile.
Well, if it gets rid of refraction, shouldn't you have to look in a different location to find the sun then?
Fuck it, let's use infrared camera and see what we see with infrared camera.
Infrared reveals the truth.
So I just want you, RocketMan, to look in live stream and show that this, when the sun is just like a line across the horizon, is that the same size sun?
It'll be a slight. It looks like there's a mirage coming up from the surface that's distorting the light.
But it's a solar. But it's a solar filter. What are you talking about?
It's staying the same size. It's just the light that's traveling between the sun and your eyes is slightly distorting.
Do you know what the definition of size is? Like, are you okay?
Yeah.
So at 50 seconds.
Yeah.
Okay. You think that is the same size as the sun in the rest of the video?
Well, the top cross section of it. It's not going to be the same width as the diameter, but it's going to be the same width as that slight portion of the top of the sun.
It is? Is that what you're observing, or is that what you're just saying?
Well, the sun's going to remain the same angular size. The light's going to distort.
Yeah, I know that's what you believe, dude. I know you believe that.
Yeah.
How about my video that doesn't show any...
sorry, not just your video. Sorry, Indio. So if you're claiming that because the Earth is a ball at a distance from the sun that you know the size to, and because of that the sun won't change in angular size, then we've only got to provide you with images of the sun changing in angular size. It's called the Black Swan sun. I've just fucking claimed it. So what do you want us to do, mate? Demonstrate to you that the sun does sometimes change in angular size?
Well, it does. Well, I mean, listen, you can just go through the scientific literature. Not only does it change angular size, it's been measured. And in fact, if you go on Andrew Thomas Young's website, he has a page on magnification of the sun. So what are you talking? You're just making shit up that you heard from some other idiot flat earther, and you came in here with it. It's irritating to me that you guys just parrot each other. The same wrong thing, just over and over again.
I mean, my video perfectly shows it doesn't change angular size.
Dude, once is not a trend.
Yeah. Whoop-de-doo.
Okay, there's lots of videos out there where it doesn't change angular size. And
there's plenty where they do.
All of them that they don't change angular size.
There you go. There's your claim.
There you go.
Apart from the ones that we can show you that will.
And the one I just showed you.
A lot of...
Yeah. A lot of
glare.
So baseless claims now.
Well, no, you can tell there's glare. You can. So the sun looks like really twinkly. The sun has like bright, sharp edges pointing out of it.
When it goes down, what obstructs it?
What obstructs it? The curvature of the Earth.
So physical obstruction that we can demonstrate to you that is, optical. Say refraction again. I bet you haven't really got a clue what you're talking about, have you?
Yeah. I mean, the video that Miguel posted is just really bad.
You just see it. You just see a lot of it, and you don't know what it is. And because you see a lot of it, you make baseless claims about it. No one's saying that refraction doesn't exist, but you require the surfaces of the Earth to be curving to cause physical obstruction. Being, as you said, refraction, then you must understand, mate, that you've never seen it. So how can you declare that it's there? Because what? The sun's going behind it, even though it's optical. We're going to go back around and around.
The sun is being completely obstructed from the bottom up.
Oh, really?
Yep.
Wow.
By what?
Ethically from the bottom up, he says.
This is cult chanting, dude.
So I did post a GIF about the sun. When you zoom in, okay, it appears what you said, but when you zoom in, it doesn't. So it's about human vision limit, okay?
So it's being obstructed bottom up by a geometric horizon?
Yep.
Okay, can you show that geometric horizon?
Look at obscuring the sun, or if you want to pay 445 grand, you can go on Virgin Galactic's flight.
No.
See what?
Is that horizon at 1.2 times the square root of the observer's height in feet? Or have I forgot about refraction, making that horizon optical and not physical for your sun to go behind? We've got to do that again. You've not seen it. but you declare that there it is, seeing it, you idiot.
Okay, let's get this down there. Is the horizon in apparent position or is it physical? Which one?
A horizon is a apparent thing, but
okay. So if you're saying the horizon, the apparent thing, blocks something, but it's not really there, it's only apparent, you're saying that you watching something get blocked by what? An optical effect.
No, a solid.
What do you mean no?
A solid object.
So the horizon is a solid object?
No, the solid object is creating a horizon. The horizon is a product of the object being the shape that it is.
Okay, where that solid object ends and the sky begins, right? That dividing line, that horizon, is that the physical end of that object that you can see? No, it's just the apparent end. So there could be, after that line, there could be more of that physical object, or there could be less of it.
I guess. Yeah.
You have a problem. Scrub the launch. Scrub the launch.
Okay. Houston, we have a problem.
Look, you're using a horizon line to demark where there's physical Earth and where there's not. As soon as you start saying, oh, that line is just an optical effect, now you don't have an actual physical position in space to make claims about something's blocking something. Because that physical position is just an apparent position.
You can determine at what distance does the object cause things to start to obscure things.
What object? You don't have an object.
The thing under your feet.
Yeah, but where that object ends, right? The limit of you being able to see that object, the horizon, that terminator line between the sky and the ground, you said is optical.
Yes, it's where your tangent line of eyesight.
Oh, no, okay, that now it's geometric again.
You said
yeah, dude, you can't have it both ways no matter how hard you struggle, dude. Okay?
You said tangent line.
Yeah, I know, so it's physical again.
Yep.
So, Rocket Man, you do understand that since we're we're closer to the ground, so where the ground meets the sky and the horizon is the smallest angle of our vision.
Yeah.
So that is why we have such a limitation. It's because we can't resolve that angle past the horizon. We can't.
Well, if you change your angle, the horizon's just going to...
Yeah, but let's not even worry about changing the angle. Think about that for just a minute and see that you can't have a physical horizon. Like, that's our argument. That's where we're coming from.
What would happen if I was to be able to demonstrate to you on a surface that the horizon appears beyond the object in question, that the object in question, because of your narrow angle of view across that surface, you're low down, starts to disappear from the bottom up? As in the horizons beyond it, what you say would be the physical curve of the obstruction where we start to see the shape, but the object in front of it is start to disappear from the bottom up. Now, we would have to say that that would be a optical phenomenon, right? Known flat surface, horizon beyond it, boat disappearing from the bottom up. That's be declared as an optical phenomenon.
Yes.
Yeah. So without just cherry picking, because this is what it is, if I can and will demonstrate to you what I've just said, then you must understand that because I can demonstrate things disappearing from the bottom up on the known flat surface and it to be declared by everybody understood as optical, then you can't just say physical obstruction is the reason why things disappear from the bottom up.
If you could show me something disappearing on the bottom up on a completely flat surface, I will more than happily hand you the point.
Cool, live stream.
Oh, snap, let's do it.
Wait.
I love it. Hold true to your word.
I will get this 3-minute 8-second video of the guy who put a camera on the football field and started walking away in the middle part of the football field into the end zone, and that is exactly what's happening. So you can look at this, my friend, and this is exactly what's happening with the sun. And I'm going to post it. It's 3 minutes 8 seconds long, and I want you to watch it.
I didn't know football fields. I didn't know fields were completely perfectly flat.
From end zone to end zone to end zone, end zone to end zone, they are flat. If you're going sideline to sideline, some are built for water, so water can usher itself off. But end zone to end zone, they are flat because you can't have one team going uphill and the defensive team going downhill. It doesn't work that way. So end zone to end zone, 50-yard line, they are flat.
I played cricket. One of the most famous cricket grounds of the world, Lord's Cricket, a 5-degree slope.
Wow, that's wonderful. So,
why is any other field different?
Because we're talking about professional sports, and we can.
That's not a professional field.
Oh, hold on. No, it's not. But we're now taking one instance after the other. I did post the image of a boat, an RC boat. Now, if on a lake, so the only curved surface would be the curvature of the Earth. That would be the one in question. But this RC boat disappears before that curvature of the Earth should be in play. So therefore, we're all going to sit here and go, well, being as that's not the curvature of the Earth because the RC boat is starting to disappear before that mathematical geometric limitation of 1.225 times the square root of the observer's height in feet, before it starts disappearing at that one, we're all going to say it's optical. So you can't sit there and say just because I assert that the only reason why I can't see the bottom of that boat is curvature, physical obstruction, and completely ignore this. It's black swan, my friend. If you're going to assert that all horizons are physical, then they must be where it mathematically dictates. It isn't.
It'd be good if the topographical surface of the medium that it's on isn't constantly fluctuating.
Yeah, that would be good, but unfortunately that's where we live. And then you're just going to say refraction because of the distortion of the air above the surface of the water, therefore shooting yourself in the foot when you realise that no one's seen this curve to make a mathematical calculation.
Did you just say the waves make things disappear bottom up? Did you just say that?
Yeah.
No, but I'm saying in that specific case, the waves are obstructing the boat.
Oh.
Yeah.
And that can't happen on the ocean?
It depends how close you are to the water and the angular size of the waves to how close you are to the camera.
You can watch this video and it's not waves, dude. It's really simple. It's not waves.
It's not an established flat field either.
Oh, really?
Yeah.
So this lake is 1,000 feet long.
What?
This lake that this was done on in voice sex. Yeah, with the RC boat. Yeah, this lake is 1,000 feet long. Do you know how far the horizon's supposed to be? 2,600 feet to the horizon. So how come the boat disappears before the horizon?
Because the very small waves close to the camera create a...
Well, you can watch the video. It's not waves. It's not waves.
Okay.
You can watch the video. It's not like, okay, that's the way it is. It's not
You're
waves.
arguing against the water, right? You're arguing against the example for water. You're arguing against the example that's being provided on the field, saying that it's not perfect, right? Yeah. What would constitute a perfect field for you in order for this to be a test that you would accept?
I'd say maybe a train line that's a mile long, show there's no elevation change, and show the train disappearing bottom up.
So a field that's been constructed to be level by engineers, that doesn't work for you, right? It's been constructed to be level. It's been measured before they laid the concrete and everything else for it to be level. That's how they made the field.
I'm not like
I need to get
okay. What he just said is disingenuous anyway. That would not satisfy you because you guys think level's curved. So if you leveled the railroad tracks to some distance, right, you would just say, oh, that just follows the curvature of the Earth. Because level's curved. Good try. Okay? Good try.
I'm trying to think of one that would work, but the issue is we live in an atmosphere, and
Yeah, so you've never measured the curvature of the Earth, you just assess it.
So, I mean, cool. Listen, at this distance, there's no drop in the curvature of the Earth. It's not waves, okay? This has been replicated multiple times, over and over and over again. There's even one where you can't see the boat at all, but you can see the spray from the boat's motor spraying water from under the horizon. There can't be any under the horizon. It's not far enough.
Can I ask why lampposts on roads don't disappear bottom up and just converge to a point but never...
Okay, why don't you just address this? Address this. Why is this boat disappearing?
The boat?
The RC boat.
Yeah, I'm looking at it.
You didn't even look at it.
Yeah, he hasn't looked at it in India. That's why.
Oh, here's another one.
He hasn't looked at it. Doesn't care what we say. He's not going to care what we show. He's just got a misconception and a hill he's going to die on.
Well, he's saying that it's disappearing. He's saying it's disappearing. Yeah, you're saying it's disappearing due to waves, though, and your claim before is that it must disappear bottom up due to curvature. So you kind of wrecked that claim by saying it's waves.
Well, looking at it, the waves aren't obstructing as much as I originally thought. I'll give you that, but it looks like there's a severe amount of surface refraction that's glancing off the surface of the water.
So not curvature, then. So not curvature, though.
Well, yeah, you can tell there's like a mirage on the surface of the water.
Yeah, it's optical then.
So you don't need curvature for something to appear to disappear bottom up, is what you're saying. Curvature isn't required for that effect.
We're all going to sit here afterwards and sit around the campfire and kumbaya, it's optical. Kumbaya, everyone, it's fucking optical, innit, mate?
I got an infrared one from land to land.
RocketMan at 15 and 17 minutes after the hour, I posted a video, not a picture, videos of flat surface when people are walking away or a boat is going away. It on a flat surface, if you get far enough away, you will lose things bottom up. It is not over your imaginary fictional fairy tale curve. It is because of how your eyes see things when things move away. So 15 and 17 minutes after the hour, please look at it, love it, and live it.
Well, Jim, surely he knows that because he just gave two different ways that things will disappear bottom up over a flat surface.
Mm-hmm. I mean, it feels like I'm going to have to get a brick out and build a wall very, very far away.
And you've got the two horizons, too, you got to throw in there. So there's like 4 possibilities at this point.
You do understand, RocketMan, that you can't see forever. For example, flies. You can't see a fly that's, a mile away because it's too small to see, right? So you understand that with distance, things look smaller, right? So eventually, because of that distance, you won't be able to resolve it. It would have disappeared because you can't resolve that angle. Good.
Yeah.
So me and you on a known flat surface, and I've got a brick, and I'm going to slide that brick on the floor away from you until it reaches a distance where you can't see the fucking brick anymore. And then what I'm going to do when you put your hand up in the air and say, hey, Jedi, I can't see the brick anymore because I understand it's too far away for me to see. It's too small. I can't resolve it because of its angular position at that distance. I'm going to start to build a wall. And then eventually you're going to start to see that wall because it's increased in angular size. I'm then going to build a fucking cathedral. Now, you're not going to be able to resolve the bottom of that fucking cathedral that I've built because you lost the ability to resolve that first brick that I placed down. I could have built it further away. You could have lost the ability to lose 2 bricks, 5 bricks, 10. But I guarantee you, if it's big enough, it has a taller angle like a cathedral. You see the top of it, but you won't be able to resolve the bottom of it.
Okay, but the top of the cathedral's further away from your line of sight.
Hey.
What?
Well, yeah, if you're stood on the ground and you build the top of the cathedral...
So the hypotenuse of your triangle is longer than your baseline, I get you. So you've increased your angle. It's kind of similar as going up, right? Increase your angle and then you can see a little bit further off the surface. We're just going to be talking about angles a lot.
But so is the reason, I don't want to straw man, I just want to clarify, is the reason, as you state, that things disappear due to them being too small, or is it a mixture due to the angle as well, or is it purely because they get too small to see?
It's not purely anything because we have to understand with distance there's a lot more atmosphere in play. So we've got problems. But we have to understand just that basic angular geometric function. That brick is going to be too small for you to see until I increase its size and build a cathedral.
Okay. So if I said, the whole going up in a very tall building and watching the sun set again in its entirety, even though you're, much farther away.
Okay, so top of the Burj Khalifa, I can't see the sun at the bottom because of sunset. I go up and I can see the sun not setting again. Yeah, because you've increased your angle across the surface. And again, remembering that wasn't physical curve of the Earth that obstructed the sun down there, and you can't declare that it's up there either. Because you still need it to be physical, and we're just showing you the horizon's optical.
So I want to show you something. Look in live stream voice text. This is a clip from a video that's supposed to be a ship over the horizon. Yeah. Now, remember what you said about it's mirage at the bottom? Is this image mirage at the bottom? This boat. That's not a sea painted on the boat, buddy. That is where the anchor is. And that underneath the anchor is a reflection of the anchor.
I'm not exactly sure where I'm looking in the
live stream.
Yeah, no, I'm looking at
the white part of the ship in the front of the ship.
Okay. Yeah.
Okay.
Yeah.
So this is mirrored. And if you look at almost, I would say, any so-called ships over the horizon, you will see the same mirrored effect.
You will.
What you call it a mirage.
Okay.
It's not Earth curve, dude. Just like the image I showed you with the RC boat, that's not Earth curve.
But then the boat keeps going and continues to disappear.
So imagine this little marine layer, right, that's reflecting everything that you can't see past. So you're not seeing, like, underneath this dividing line, where the reflective line is, you're not seeing any of the boat. You're seeing a reflection of the top of the boat, right? You don't actually see the boat underneath this. There's no boat underneath this dividing line.
Okay. Yeah.
Okay. Now imagine if this was a brick wall instead of this dividing line. And it sailed away. Would it appear to sink down into the brick wall?
So you're saying where
it would get smaller in angular size, right? But you'd still see the reflected top. And it would appear to sink, because it would converge, right, into the center of the reflection.
See, yes, I agree it would converge to the center, which we don't see boats do. We don't see the top converging with the bottom.
No, it's because the surface.
So what are you talking about?
From what I'm saying, you're saying like almost the bottom melts into the horizon line and the top and the bottom converge.
I've watched lots of videos of ships over the horizon. Lots of them.
Okay.
First of all, it's a rare occurrence to even observe it in the first place. Okay? Should happen every time a boat goes out to sea.
Why won't they pay attention to my shit? It's just so stupid. It's so stupid. Blah, 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 sorry.
What?
The point is that this is not Earth curve. It's not caused by Earth curve. The RC boat's not caused by Earth curve. So your claim that the reason we can't see the bottom of things is Earth curve is just wrong. It's factually wrong.
Okay.
Well, Indio, it's so wrong. It's fourth grade wrong. And we have adults running around who are 30, 40, 50, 60-year-olds telling us what fourth graders would argue with. And it's really, really insulting to us because we know what they're doing. They're debating at a fourth grade level. And I personally don't want to debate with a 10-year-old.
Now, Rocket Man, if you had a 10-foot pole, right, and there was a light on the top on the ground and a light on the ground, right, it's attached to the pole, but it's at ground. The light is attached to the pole at ground level. There's a light on the top, and the pole is say 100 feet high, and you got the pole attached to some pulley, right, and just you turn the lights on and you pull the pole away from you, right. So it's going off to the distance. It's a mile away, 2 miles away, 3 miles away, 4 miles away. What does it look like with those lights, right? They appear to converge together, right?
So if I had
like headlights, right? Like headlights far away, they look like one light, and as they get closer, they separate. Right?
Yeah.
And you see two headlights. So when the headlights are far away, what happened to the 6 feet in between those lights?
That's got to do with Snell's law. I need to touch up on that. I remember doing that.
There's nothing to do with Snell's law.
Snell's law, man. Nothing to do with Snell's law.
No, it's just at a far distance on the level plane.
Yeah, and you can't see that separation, even though there is a space there. You can't see the separation. Now, if you took those lights, right, those car lights, and you turned that vertical instead of horizontal, it's going to look like the top light and the bottom light's going to come up until it reaches the horizon, and then the top light's going to come down. But the top light's going to keep coming down, and the bottom light's going to stay at the horizon, and the top light's going to sink into the bottom light. Visually. I'm not talking about physically sinking. Visually sinking. That means the angle of separation is going to get smaller. But the bottom light is no longer going to raise up. So visually what that's going to look like is the top light coming down into the bottom light.
Sorry, it wasn't Snell's law. I was wrong. It's called the Rayleigh criterion.
You didn't even listen to the thing I said because you're fucking reading.
You don't know anything about it, bro. You're just looking up these terms now and you're spouting them out. You've heard them somewhere. You don't know anything about it, bro.
The Rayleigh criterion is the rough angle between the two objects.
Okay, yeah, go off. But somebody was having a different conversation with you just now. Try responding to that.
Yes, because you were saying that the two lights look like they appear to go into one.
Yeah. But there's still a separation.
Yes. But the reason they...
So when you see two lights and you see them converge and you see one light, what are you going to think? You're going to go, where did the other light go?
No, I'm going into the Rayleigh criterion.
You just learned about it 3 seconds ago, dude.
No, because I hadn't used it in about over a year. It's the visual angle subtended between two objects, the minimum angle between them before they appear to merge into one object, and it's roughly equal to the wavelength of the light reaching your eyes divided by the distance of those objects to your eyes.
A distance on a flat plane.
No, it's not distance. D is the diameter of the optic times 1.66 the wavelength.
Oh, it's visual. Oh, is it optical? Come by.
Fucking Christ.
Yes, because we live in an atmosphere, so everything we see is optical.
Yeah, sorry.
Everything you see is its apparent position.
Yeah. So you're now the fucking cheerleader of the Kumbaya Brigade and shouting that it's optical. Fuck!
Well, you live in
I told you that we were good. Yeah, so it's all optical then, isn't it?
Yeah, but it doesn't mean it doesn't
exist. It's not physical. Oh, no. No, it does exist when the sun goes behind it.
Everything you see is optical, but you can still touch things. Everything you see is its apparent position. It's slightly off from where it actually is, but you can still touch it because it still exists.
That's gonna be.
There's literally no evidence for a goddamn thing you're saying, bro.
Can you prove? Yeah, I was like, can you prove any of that whatsoever? No.
I hope you never need laser eye surgery, mate, because that eye surgeon can't see your fucking eye in its
Don't cross the street, bro.
Jesus.
Bring your calculator when you cross the street because you might want to account for refraction.
Okay.
When you put your hand in front of your face, is that your hand that you see? Or is it somewhere else?
Another one that doesn't actually believe what he's saying. You don't actually believe
not exactly where it is, but it's close enough to not really make a difference. Or not make a difference at all, really.
How far away does something have to be for it to start making a difference? And would it then be an optical phenomenon? Depends. Yeah, of course it depends. Depends on
that. Want it to be
depends on atmospheric conditions and whether you've snorted or inhaled enough shrooms that day to be able to see straight.
Okay, can you tell me what is optical in Black Swan example then?
What is optical in the Black Swan?
Yeah.
Everything you see, the giant case of refraction due to the.
Okay. I will ask you another question. You said everything is optical. Is it water, ocean between two oil rigs real or optical?
The water is real, but where you perceive it to be is optical.
That's what I'm seeing between two oil rigs. Is that real ocean or the reflection of the ocean?
God, it's like he didn't get what Injo put down.
Are you on about the water, or are you on about where you see the water?
The water between the oil rigs. Okay, there's water, so the rigs aren't touching each other. There's water in between them. There's one at 6 and 9 miles. So in between those rigs, there's 30 miles. Is that water real or optical? That's what Sasha's asking.
That is real water that you can touch.
Okay, that real
so
water.
the hand in front of your face isn't a real hand.
That real water is not optical then.
No, but the position of where you see it is optical.
What are you saying, man?
Where you observe the water to be is optical.
No, that's physical because that oil rigs are in ocean. That means that water exists. I can see that water.
I'm not saying it doesn't exist.
Yeah, that water's flat between those two oil rigs. You can see it.
That means it's not optical. It's physical.
The water is physical. Where you observe it to be is optical, but the water is physical.
Well, the water's going to stay in the same spot whether you're observing it or not.
Water's moving quite a lot.
If I put you between two oil rigs on that water, am I putting you on some physical thing or some optical thing?
You're putting me on a physical thing.
Good, great. If I put you behind the second oil rig, did I put you on optical or physical thing?
What, on the water?
Yeah.
On a physical thing.
Yeah, good. Why we have that physical thing behind the oil rigs?
Why do we have physical things behind the oil rigs?
Yeah, that's water.
Because the ocean doesn't end where the oil rigs are?
My goodness me.
Why
He's
we
not
don't have
arguing out of good faith.
Why we don't have a sphere, man? With the geometric horizon 1.22 miles, and we have a physical water behind there.
I just realized the space between those oil rigs is twice the distance the horizon is supposed to be.
Exactly.
That's crazy.
Cool.
Cool.
The globe model curve shape 1.2.
Fuck me.
Cool.
That means if the first oil rig was on the shore with the camera, okay, this would be a black swan. Okay, because you can see all the water up to the second oil rig. That means the horizon would be 2 times too far at least.
Okay.
Oh dear. Oh dear.
How you can say the sentence that water is physical, but when you're observing, it's optical?
I'm not saying the water is optical. I'm saying where you appear it to be is optical. The water is physical.
It's an illusion. It's an illusion, mate. That water that you see isn't where it physically is it? It's all an illusion to these people.
But by what he's saying, every single object on this, Earth realm, whatever, would have to be fake then, and not in its correct position. By what he's saying.
Yeah,
well,
exactly.
Define
correct position.
Well, weren't you just? Well, let me ask. I want to ask you a question. Weren't you just saying the sun is the same angular size all the time?
Pretty much within probably.
Isn't that just optical then?
Throughout the year.
Isn't that just optical then? It's not physical.
Because we're looking through the atmosphere.
I wouldn't say it's purely optical, but you see the sun.
Oh my god!
The position you see the sun is optical, but the reason the sun stays the same angular size is geometrical.
Which it doesn't. That you just kind of half claimed just a second ago. It kind of eased out of your mouth. Yeah, but in a bit it does. Yeah, it does change an angular size.
The reason you see it.
It has got atmospheric magnification. This is a demonstrable effect that you can't remove.
He's got this barrier. He's got this barrier with himself. It's not good.
I'll admit the sun does have atmospheric magnification, but during the day, it stays the same. Or during the same atmospheric conditions, it stays the same angular size.
During the day, huh? When do we see the sun that's not during the day?
Physical.
The nighttime sun. When did we see that?
Depends how high up you went.
Jesus
need to
Christ, bro.
You need to understand. You said this. The position of the physical water is not there.
Not quite. It's very close, but not exact.
Okay, that you said. The position of the physical water, what is physical, it's not there. That's not right position of the physical water.
If everything is optical and does not have a true geometric position, how was the gold model constructed in the first place?
How's the water obstructed?
How is the gold model constructed in the first place if we're not seeing anything in its true position?
Yeah. So remember when we said that you ain't seen the curvature of the Earth? That's what we're talking about. Being you keep the same refraction and the atmosphere, and so that's not possible. Then is it? That's the conclusion that you are literally going to have to concede to because it's coming out of your mouth. You can't see it, so how can you measure it?
You can see it. It's just apparent.
Can you measure? Hold on. Yeah. So what's its true position then? If it doesn't appear to you visually in its true position, then you can't see it in its true position because the atmosphere is in the way. That's what you said 20 minutes ago. We'd have to take the atmosphere out. I said, yeah. We all got to that conclusion because we don't see it in its true position. So how can you make a declaration to where its true position is?
By taking into account atmospheric conditions.
But you've got but hold on, you've got no true position to backwards engineer any calculate. Hold on, you've got no true position to backwards engineer any of your calculations to have that fucking baseline. You don't know where it is.
Well, to make a baseline, so when we look at objects around the room, the amount they're shifted by due to atmospheric conditions is you can consider as negligible. Due to so that you can use it as a baseline. It's not perfect, but
awesome. So in my room where the surface is flat, measured flat, and the fucking builder's made it flat for me. Yeah. When I'm in my room and I notice that these things are out of position, do I then assert that my room is curved and the reason why they are out of position is because of the atmosphere is projecting the image to be flat? And we can understand that refraction is going to exist anyway, because the atmosphere is going to exist anyway, because we're breathing, whether the Earth be flat or a ball. So we've always got to take account for that anyway. But you're going to bastardize the idea that the Earth is a ball with a radius value to it and backwards engineer anything that you see to that presupposition that the Earth has a geometric horizon. You haven't seen it to prove your mathematical supposition in the first place.
Would you say that I haven't seen those oil rigs because refraction has occurred?
No, I'm telling you that no one can see, according to you and everybody else, because we understand refraction exists, the curvature of the Earth. So how could you measure to it? You haven't got a baseline to backwards engineer any refraction value to it, and I don't want to suggest that maybe you don't even know what refraction is. But ultimately, the atmosphere between you and the object, you would have to know every incremental piece of data along the way. For example, the heat, the pressure, and the moisture within that area, but you're not going to, and no one ever has. So you're just going to start asserting refraction as a magic that you can use to assert your idea. You've got no proof for either thing now, not what's between you, not the refraction value, and most definitely you've never seen the curvature of the Earth. So this argument really has to stop, and you have to say, shit, I haven't, and no one, it's not you, no one has measured the curvature of the Earth, and that is not physical obstruction.
Okay. I mean, look, I do love these talks, and but we all know that it's just going to go round and round in circles.
Because you won't make the concession. Yeah, we get it.
No.
But
so, well, it's all a bit of fun. At the end of the day, you know that I'm not going to persuade you, and you know that I'm not going to give you what you want. So, I'm happy to leave it here for tonight and just not have a nice laugh, chat, or whatever. But if possible, I don't want to sway how your debates go, but like we did with the rocket exhaust, would it be okay to talk about other topics other than like optics and horizon, because it always seems to tend towards that, and we just end up in a feedback loop.
Hey, RocketMan, if you woke up tomorrow morning and you had an epiphany that the Earth was a stationary topographical plane, not a spinning space ball in outer space, what would happen to you? How would your worldview change?
I would first have an incredible fight with the entirety of science.
Okay.
Well, epiphanies don't mean it's true, I guess. I'd be like, why do I believe this? Let me talk to people.
That's a bad faith. You're using bad faith in this argument. You have to take every talk and things like that in a good faith argument. Hypothetically speaking, using the good faith argument, if you had woke up and, all scenarios included, Earth was flat, you just discovered it, it blew your mind, you had your epiphany, how would you therefore go about doing that? What would you do after that, is what he's asking. Not like, if it is. It's just you have to use the good faith argument whether you believe in that side or not.
Okay, so you're saying that if I woke up and the Earth did actually turn out, giant scientific breakthrough.
Whatever your necessary proof is for you, you had found that, and then the next morning, that was your epiphany.
If it would come as a conclusion through science and the scientific community had agreed upon it, and that was the general conclusion, then I'd get onto this Discord and I would laugh with you guys about how much of a stupid idiot I was, and we could all laugh about it, and you could take the piss out of me for as long as you wanted.
So RocketMan, you said scientific consensus. So
yes,
you are saying, RocketMan, before you decide that we don't live on a spinning space ball, you would have to get the approval of others and not think for yourself. Is that what I'm hearing?
No, I would get the peer review of millions.
People would be thinking for you, RocketMan, correct? Yes or no?
Myself.
You would? And I know you need to go. What experiment would you do?
Oh, there's so many to choose from. That's a good question. I'd have to come back to you on that, on which one I'd specifically choose, which would be the best one. But whatever it may be, I would perform it. I would then show my results to other people that had also done the experiment, compare the results, make people check that my results are valid, and then if they are come back as valid, then yeah.
So how many experiments have you done to prove the Earth's a globe?
Personally, me?
Yeah.
0.
There you go. Other people think for you. The greatest gift you can give yourself, RocketMan, is the ability to think for yourself. You have abdicated your whole life the ability to think for yourself.
I've also developed logical reasoning.
Awesome. So along those lines, can I ask you a quick question? Hey, so just one quick question before you go. What reason do I have to doubt that the Earth is flat, if any at all?
The fact that Earth is a sphere is used every day by millions of people across the world every single day.
It is perceived. It is not used.
Yeah,
I can tell you from military experience in all of our ballistics, whether it's missiles, firearms, aircraft, ships, everything is using a flat plane.
Navigation.
I'm scared to disagree.
You can disagree all you want, but we have the manuals.
Hey, you're fighting the wrong person.
No, I get it, but don't go now while saying things like science and scientific experiments, because, man, I'd like to challenge you on the fact that maybe you don't know what a scientific experiment is. And also, please don't say that the Earth is practically used every day as a fucking ball, because we'll just point out the instances where the Earth is practically used as a flat stationary plane, especially when we're talking about navigation, communication, ballistics, blowing shit up. How the world is run every single day requires the Earth to be a flat plane, and has done for thousands and thousands of years. For example, we use triangles. Sorry, we use triangles to navigate across the surface of the Earth. Triangles require 3 straight lines, meaning at 3 corners, vertices, where the interior angles reach 180 degrees through mathematics. So basically, we understand that the Earth can't be able to build a fucking triangle upon and to gain an elevation angle up to any celestial body in the sky. This is celestial navigation, which requires the Earth to be flat. So, I don't know, mate. Do you want to go now? I'll open the door for you. Or do you want to be challenged on what you just fucking said?
All I would say is, from what I've experienced in life, you guys have experienced different to me, but what I have experienced, I've come across lots of people that have used it from what they have told me. Like, you have found people that haven't used it from what they have told you and what you have found. We are going the same argument from different sides.
RocketMan, do you want to
point
hear
out
what?
a double standard? I just need to 1 sec. So he said if he found out the Earth was flat tomorrow, he'd go and do experiments, and then he admitted to himself that he hasn't done any to confirm that the Earth is a globe. So why the such strict double standard?
Sorry, that was very muffled. I'm just gonna. Did you say that? I would say if I would do experiments to see if the Earth was flat, but I haven't done any myself to prove it was a globe.
Correct.
Yeah. Mainly because.
No, RocketMan, do you want to hear what Jedi have to say about navigation and using navigation from the ancient time?
But hold on 1 second, side. Let him address what Timbo just asked.
Okay.
I want to hear this explanation. I'm intrigued.
I would say because I've seen the reason I haven't done any experiments to verify for myself that the Earth is a globe is because I've seen the methods that people have done. I've used my logic of reasoning to establish that that was a very valid experiment that was performed, and therefore the conclusion they came to was also valid. Now, if I came to the epiphany that the Earth was flat, it would be a giant shake to my worldview, and I would be more than happy to go out and test it because it would be a very exciting thing for me, for my entire worldview to change. That is the reason why I haven't done it yet, but I would if I had the epiphany the Earth was flat. To address what Jedi said, all I would say is to have the debate about navigation, I would talk to someone who uses it. I don't use it. I've just seen and heard people talk about how they have used the Earth sphere. Like, it's debating with the wrong person. I've just seen what I've seen on the internet. I can't fight for them. If you want to talk about navigation, I would say talk to someone who has used navigation. I haven't. I'm more than happy to leave it at that.
Okay, but you know what a triangle is, right?
Yes.
Good. Awesome stuff. So we'll talk about triangles another time. You don't have to be a genius as an appeal to some kind of credentials to understand basic shit, like a triangle. So, we can leave it with that one, but we're definitely going to have that conversation about the scientific experiments you do that think can prove the shape of objects and the category error within that statement I've just made.
And don't worry, I'll make sure to leave out straight lines because I know that's a sensitive topic for Heretic.
Sorry, what's that?
Or just ban. I was just talking about the straight line debate that we've had a few times. Just a bit of banter.
Oh, that wasn't a debate. That was just you being a retard as usual.
Okay.
Yeah, an arc isn't a straight line. Google yeah. Go Google it.
I'll take your word for it, mate. We appreciate you being around, and you have been a really, really good sport, man. So we do appreciate it. And you are welcome again, for sure.
Yeah,
for sure.
I'd like to say thank you. It's been a lovely discussion again. It's been a lot better than what I've had in the past before, and it's made me a lot more enthusiastic to come back again and have these talks. So I appreciate having your time, gentlemen and lady.
Well, we appreciate the fact that you want to come back. Good night, my friend. We'll speak to you again soon.
Tags! What is your profession?
See, old friend, I brought more soldiers than you did.